Hello, everyone, and welcome to BFW 2401. This is week 7, part 2. Now, we are continuing with the credit risk for single loan. So let me just start and we can. So this is the second part. And we are talking about the continuing in the models. And today we are in this part, we will talk about two models. This, which is the term structure and the mortality rate deviation of credit risk. Remember, all of those type of models is actually trying to create a benchmark. Later on, in week 8, we'll continue to talk about this. But today, we are just talking about these two models. Now, let me start with what we call the term structure. Term structure, the term structure is actually referring to the structure of the interest rate. Now, the interest rate, we can have a risk-free or we can have a corporate rate. As you can see, if you look here, if you look here, for example, so the term structure is actually either we are talking about risk-free rate, defined as I, or corporate rate, which we call it in this context as K. And the difference between K and 1 is the premium of the credit risk. And the concept is, if I have, say, $1 million today and I want to invest it, I can invest it actually without a credit risk, zero credit risk, if I invested in government securities or treasuries. And this, we call it credit risk free. Yes, the rate of the government of the treasuries is less than when I give loan to corporates, which is K. Why I am increasing the K over the I is actually about my anticipation of having some credit risk. So actually the K minus the I is actually the premium. And this is what I'm talking about here. So the premium here is actually the difference between K and I. Now, taking this concept, if I have $1 invested for 1 year, so if I am investing in corporates, I'm expecting to receive $1 plus K. If I'm receiving, if I'm investing, if there is no credit risk in the K and C company, this corporate is a AAA, which is defaulting is 0. So in this case, I will receive whether I invest in corporate or I invest in the risk-free, I will get the same return. I will get my dollar back plus the I. But then this is not actually the fact in life. Corporates will default. They are not risk-free like the government. So there is a probability of payments. So I have to take the probability of payments and multiply it by 1 plus K to equals 1 plus I. And this is actually reflecting this issue, which is the difference between K and I, which equals P. So if I want to calculate the probability of payment is actually, I will take 1 plus I over 1 plus K. So assuming, based on this concept, I can calculate the probability of payments. And the probability of payments is actually, if I take the probability of payments, which is 95%, if I assume it's 95%, then the probability of defaulting is actually 1 minus the probability of payment, which is 5% in this case. So these 5% defaulting is actually compensating me. I'm compensating this defaulting with this premium. This is how the story works. So let me go now to proportion. Let's take an example. So we have also another issue called the collateral. Sometimes I can take a collateral. And the collateral is type of security, like it can be if it is a business loan, I can take the factory, the land of the company, the factories, any other assets, tangible assets, and take them as a security. If the customer does not pay, then I can sell those assets. And by definition, if I have a collateral, actually my credit risk is less. So if I want to include the collateral in this formula, I can calculate the premium. So if you look at this, the payoff when I have a collateral is the probability of the payment of the in terms of defaulting, and I have to take. So this is the probability of defaulting, 1 plus minus P, which is, if we are talking about 95% probability of payments. Now this will be 5% times the collateral times 1 plus K, which is my principal and return, plus the probability of payments. So this is the probability of defaulting. This is the total payoff plus the probability of payment. This probability of defaulting and probability of payments equals actually 1 plus I if I am test and risk-free. Please look at it from the payoff. I'm talking about payoff issue. Now, the payoff is actually is expected to be received if the loan is defaulting. So if the collateral is more than 1, then the required premium will be less. Will be less for any probability of payment, probability of defaulting, 1 minus P. And if I want to calculate it, the premium now, K minus 1 equals the premium. This is the premium, and this is the way we calculated the formula. And we can calculate actually the premium using this formula. Remember, term structure now is giving me a pricing. It helps me to price. So as you can see now, the collateral and the probability of payments are perfectly substitute, or they have negative relationship, which means they take this shape. If this is the probability, if this is the collateral, and this is the probability of payment, in high probability, in high collateral will be less probability of payment. But if a customer is very good and I take only small collateral, then that means this customer high probability of payment. So it's actually a negative relationship between probability of payment and the collateral. This I want you to understand, so you understand, you can get some sense about the relationship between the collateral and the probability of payments. In other words, a good customer, I will take for him less collateral, and I didn't say a bad customer, but a customer with less probability of payment, I will ask him to provide higher collateral. And this is why this relationship between probability of payment and collateral are negative relationship, and they are substitutes. Okay, let me go to the next one. So let's take an example. So if this is, if we are taking, if we have a loan of for more than 1 year, say this is year 1, this is year 2, this is I, and this is K. For the first year, this is I for this year, second year, and this is K for the second. So this is 2, and this is 2, and this is I1. and this is K1. So the difference between the probability of payments and the probability of defaulting is 5. I'm taking 5.8, which is between the difference and between K and I. The difference between 5.8, which is the collateral, the premium here is 5.8. The premium here is 7% in the second year. So if for the first year is 10% and the collateral and the K is 15.8%, now I can actually collect the probability of payment using this formula, and I find it to be 95%. I'm just using this formula. I'm not doing anything. I'm using only this formula, which is here. So I get 95%, which means for 5% defaulting for this company, I'm taking 5.8, which is the difference between K and I here. I'm taking 5.8%. As you can see, it's here 5.8%. Now assume we have a collateral, and this collateral is more than 0. Then in this case, if I is 10%, and probability of payment 95, and the collateral is 90%. So in this case, I can actually calculate the premium. So the premium is, using this formula, is actually 55 basis points. A drop from this one to this one. From 5.8 to only 25%. This is because the company provides a collateral or a guarantee of 90% of the loan, which means actually the credit risk is only applied for 10% of the loan. For that company, because of the high collateral, the premium is less. So the conclusion here is the higher the collateral, the less is the premium. Now, I think we are done with this. We move to the next model. We talked about term structure for 1 year. Later on, we will talk about term structure pricing for 2 years. But this is for 1 year, when there is a collateral and when there is no collateral. Now we go to the next model, which we call it credit risk mortality rate deviation of credit risk. We usually use this for bonds, and this is there is no calculation or whatever. It's very easy one. So this is the formula of this one. We just take all the loans. If we are issuing, if we are investing in some class of bonds, this is not loans, just as bonds we are investing in, and we want to see what is the credit risk of those bonds that we are buying and keeping them as our assets. So we have to calculate the total value of the bonds. If we are because the bonds in the market are classified according to their rating, AAA, AA, triple B, BB, B. Then we have around 8 classes. So if we are taking, for example, if our investment in class B, so we'll take all class B bonds and divide them by the total defaulting for year 1 for that class. And the government issue those ones, and you can always collect them. It's a public information, you can know. And then you take for the second year. So this is actually the collateral, and you build it here in this graph. So this is actually the defaulting for the first year, defaulting for the second year, because the bond would be issued for 10 years, 15 years, 20 years, and you can take the history of those ratings and take the mortality and decide where you want to stay, where you want to invest. M3, this is 5 years. And you can see now, this is year 1, this is year 2, so this is the defaulting of year 1. We'll call it MMR, which is the mortality. Then mortality rate, then 2 years, 3 years. As you can see, if this line is steeper, which means high defaulting. If this line is just like this, which is less risky. So as you can see, it's here, and in this case, I can decide. I think the US also issue data about this, so you can find here companies. This is the mortality rates for AAA class, A, double B, all of those until you reach 2C. And you can see this is the years. If you are talking, and this is actually very, very meaningful, because if you look to AAA, they have no defaulting over all those years for actually until year 10. But if you look for ranking of C from the first year, the defaulting 786, 15.3, 1886, and you can actually move around this. I make this arrow because this is an exceptional case, because this data between 2000 and 2000, from 1971 to 2008. As you can see, in 2001, there was here a defaulting in A, which is exceptional case. This is because there was a collapse of WorldCom, which is a huge company. This is they call it the dot-com crisis, which is actually there was a collapse of this WorldCom in 2000, huge company, IT company in the US. And this is why we see the defaulting increases for this company in this year. I mean, it disturbed it was an A company, but this is just because of their collapse, they affected the whole thing, which is exceptional case. I am done for part 2. Thank you very much. I think I will stop sharing here, and I hope this 2 parts are understandable. If there is anything, we will discuss it in the tutorial. Thank you very much and have a good day. Bye-bye.